Some people are just pattern people. I'm going to put these numbers up and they're going to go, oh, they're multiplying by 7.5. They just know them. You know, it's just a brain thing. They look at them and they get it. I wasn't one of those people. You know, that's what formulas are for, to help the rest of us figure out immediately what is it we need to do here. So we're going to talk about mathematical patterns. And like it says, we're going to identify mathematical patterns found in a sequence and start to talk about formulas to find those next pieces. Now, here's an example. This getting ready is a really good example, but we're not going to go in as much depth as they have there. I want you to look at figure 1, 2, 3, and 4, and I want you to think, how did they get this 4, 12, 24, and 40 in the middle there? How did that pattern happen? Raise your hand when you think you got it. Keep your hands up while everybody else is still looking. Let's see how long it takes for the majority of the class to figure out what the pattern is. Keep your hands up. Once you see it, put your hand up. If you're good about the path right now, pile your hand up really fast. Now, what do you see? Add the rest of the boxes up. 1, 1, 1, and 1 add to 4. Makes sense for that one. 2 plus 1 is 3. 3, 6, 9, 12. Oh, give you a 12 there. 3, 4, 5, 6. 6, 6, 6, and 6 is 24. It's working. 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. 10, 10, 10, and 10 is 40. Well, once we found that pattern, the hard part is, how do you tell somebody mathematically with a formula how to generate the next number, what the next one would be? Now, we could do it with pictures. I mean, we see the visual here. 1, 2, 3, 4. We'd add a 5, slide it down a little bit, put that on each of these, and then go from there. But a math formula that would let somebody generate the numbers 4, 12, 24, and 40, that's a little tougher. So we're looking at patterns and we're trying to come up with ways to write them. Now, first off, we need to learn a little bit of language. That's the first section of every chapter is like that. There's a little vocab we all have to know so we can talk about these. And this is a sequence. A sequence is just an ordered list of numbers. And what that means is there's a first term, then there's a second term, then there's a third term, then there's a fourth term. And it just makes sense that they're in each position as you go through it. So sequences, just an ordered list of numbers. That's all that is. Now the term of the sequence is each number that shows up in the sequence. And we have to use subscripts for that. Because what this means is any term. The N kind of stands for put whatever you want in here. While this means the first term. So what do you suppose that means? The second term. So we have to have some notation in math to tell people this is the first one, thank you. This is the second one, this is the third one, etc. And those are called subscripts, and we've seen those before. They are just small numbers to the right. It's not a full-size number. Small to the right and below it just a little bit. That's why it's called sub, like a submarine below it. So subscripts are used to represent the position. Is it the first one? Is it the second one? Is it the third one? Which one is it? So, like I had up there, they've written A sub 5. Well, I'm not going to read that off as A sub 5. Most of the time I'm going to say the fifth term, because that's what that stands for. The fifth term of the sequence. So in this case, we've got A sub 1, A sub 2, A sub 3, and that's showing us first, second, and third term, and then things get a little weird. A sub n minus 1. What on earth does that mean? Well, remember I told you that this means any term. A sub n, any term you want. So, if that's the sixth term, and we're supposed to find n minus 1, that would mean you're going to back up from the sixth term by 1. Where would you be? The fifth term. So generically, we're going to read this off as the previous term. And previous means before. So when we see a sub n minus 1, we're going to say, hang on a second, that means back and 1 up. Oh, that's the previous term. That's the one right before any term. So if a sub n means any term, a sub n minus 1 means the one before, the previous term. What do you suppose a sub n plus 1 means? The next term, exactly. So a lot of what we do in chapter 9 is just get used to the math speak. All of the vocab that goes along with what do these mean and what do they say. Now here's a big one. You cannot make it a capital A. You can't do that. I know some of you don't like your lowercase a's. You're just going to have to get used to them. And that's because a capital A is for a formula like area. But in math, when we're talking about lists of numbers, sequences, and series, it's always a lowercase a. That's standard. So a capital A will make you lose some points. You want to do that. Now, an explicit formula. Explicit means it's right there. You can't miss it. Explicit is, I come in and I say, hey, there's a desk here. I hope you're going, duh. Ah, it's a desk. It's there. That's explicit. It's kind of silly to even say it out loud because everybody knows it. It's just right there. So that's explicit. An explicit formula describes the nth term, which means any term of the sequence. So here's what that means. With an explicit formula, if I want the 10th term, I just put a 10 into the formula and it'll kick out the 10th term. If I want the 1 millionth term, I just put 1 million into the formula and it kicks out the 1 millionth term. Now they don't all do that. So these are special. These are ones we want to use. So this one says we want to describe what's going on here. And we see the first term is a 2. The second term is a 4. The third term is a 6. The fourth term is an 8. The fifth term is a 10. Now here's what you need to ask yourself if you can't see the pattern. What could you do to a 1 that would give you a 2? To a 2 that would give you a 4? To a 3 that would give you a 6, etc. What would you do to get that? That's what we would do. So we would tell people to find any term, that's what a sub n means, take 2 times the number of the term, which is n. So if I want the 100th term, 100 times 2 is 200. Big deal. I found the 100th term. That's all we have to do. So down here it says, let's get used to just using these formulas. So we're going to generate a sequence, which means we're going to generate a list of numbers, and we're going to separate them by commas so everybody knows where the break is. It has an explicit formula, a sub n equals 3n minus 2. What are the first 10 terms of this sequence? Okay. Well, here's what I know. I start with 1, because it wouldn't make any sense to start with anything else. If I'm talking about a listing of numbers, there's going to be one that's there first. That's the first term. Then I'll need the second and the third. But now I think, what am I supposed to do with that 1 if I want the first term? I mean, I replaced n with 1. Well, then you just answered your question about what you're supposed to do with it. You're supposed to replace n with 1 and see what you get. So what's 3 times 1 minus 2? Yeah, so the first term is 1. So if we want the second term, what are you supposed to do? Put a 2 in for n. What will that come up to? Put a 3 in. I'm going to need to write more numbers down. 5 gives you? Now, at some point, you might be able to save yourself a little bit of time. Oh, already noticed that, huh? Just going up by 3 every time? Well, then let's just keep adding 3 instead of doing all that math. But you should generate at least the first 3 or 4 by using the formula. And that's just so you make a little math mistake. You'll catch yourself because you'll say, wait a second, these aren't going in the pattern like they should be. And then you'll know. So generate, like I said, 3 or 4 of them. Generally, you're okay, and you'll start to see the rest of the pattern. So really, all we're doing today is we're learning a little about notation. You know, if you replace the n with a 3, that means you want the third term, and you have to put a 3 into the formula to get it. So this one says we've got another explicit formula. A sub n equals 12n plus 3. 12th term. Do we have to do the first term, the second term, the third term? No. We don't need those? What should we do? That's all we have to do. That's what's great about explicit formulas. I don't have to go back and look at what the first term, second term, third term, fourth term was to get my answer. If they said find the 2000th, I'd be really mad if I had to go back and do 1, 2, 3, 4, 5 all the way down to that. So explicit formulas are great because we can get what we need right away. Now we have a lot of questions on the homework. So, unfortunately, I'm going to have to cut down the part.
Yes.
4, 3, 2, 1, 0 me. If this is all I give you for homework, how are you going to do?
Solid.
Looking good? Okay, it says generate this number of terms. So, you can generate that number of terms.
Yes.
Oh. Our textbook is so big that the teacher's edition is split up into 2 books. Chapter 9 is in this book.
Oh.
You can do 7 through 14.
No way.
So section 9-1, day 1, page 569, number 7 to 14. Let me see if there's any good repeat.
No, it's here. There's no. I already checked. They're pretty bad.
Slow. I think you can handle slow.
No.
79 to 81.
We gotta graph something.
No. You be urinated?
Yeah,
That makes no sense.
So urinated.
Don't use that urinated word.
Could be urinating everywhere.
All right, so there it is. Nice and short. Short and sweet. Oh, come on, it's sweet.